So let's just move on further towards the question number 2, which says a boat goes 30 km upstream and 44 km downstream in 10 hours. So the question says a boat is going 30 km upstream and 44 km downstream in 10 hours. In 13 hours, it can go 40 km upstream and 55 km downstream. So determine the speed of the stream and that of the boat in still water. So it means we have a situation of something of this type, as we are talking about the boat is going upstream and the boat is going downstream. So we have to calculate the speed of the stream and that of the boat in the still water. So let's just find out the value. So first of all, let us suppose we are assuming the speed of the boat in the still water and the speed of the stream. So let's just start the solution for this particular question. As first of all, we have to assume that, let's just assume, let the speed of boat in still water be x km/h and speed of the stream be y km/h. So if we are talking about the boat going upstream and the boat going downstream, then the speed of the boat upstream and the downstream will be of the type. So let's just see. First of all, according to the question, we will say the speed of the boat upstream would be of the type x minus y km/h, because we are talking about going upstream. So if we are talking about the speed of the boat going upstream, then it would be x minus y km/h. And if we are talking about the speed of the boat going downstream, then it would be of the type x plus y km/h. The speed of both the still water, or we can say the speed of the boat in the still water and the speed of the stream will get added up together. So the speed of the boat upstream would be x minus y km/h and the speed of the boat downstream would be x plus y km/h. So according to the question, what does it says? It says that a boat goes 30 km upstream. A boat goes 30 km upstream means the distance is actually given to us while going upstream is nothing but 30 km/h. And again we have the kilometers or the distance given to us while the boat is actually going downstream, which is nothing but 44 kilometers. And together a boat goes 30 km upstream and 44 km downstream in 10 hours. Together they are going upstream and downstream in total of 10 hours. So for an instance, we are talking about the speed distance time relationship. So we can say that we know that speed is actually nothing but is equal to distance upon time. So let us suppose if we are taking the time for going upstream and for going downstream as T1 and T2. So let us suppose, let's just take, let the time taken upstream and downstream be T1 and T2, then according to question it is given to us that T1 plus of T2, the time taken going upstream and downstream as per given to us, which is nothing but 10 hours, is 10 hours. So T1 plus T2 is first of all 10 hours. So let us suppose I'm calling this as equation number 1. And further we have, it can go, or in 13 hours it can go 40 km upstream and 55 km downstream. Means again we have given that T1 plus of T2 is actually nothing but 13. This is nothing but a second condition. So first of all we have to substitute the value of T1 and T2. What is T1 and what is T2? So let's just talk about the time taken going upstream and downstream. So first of all, we know that speed is actually is equal to distance upon time. So we can conclude from this particular relationship that time is actually nothing but is equal to distance upon speed. So using this particular concept, we will find the relationship in between the time, distance and speed for the upstream and downstream. So let's just talk about the upstream first. So if we are talking about the upstream first, so we can say that for the upstream we have taken the time as t1. So t1 is nothing but is equal to distance. So what is the distance covered while going upstream? So this is nothing but 30 km divided by the speed taken. So as we are talking about going to upstream, so the upstream speed is actually nothing but x minus y km/h. So this is x minus of y. This is x minus of y. So for t1, so for the very first line, we have t1 as nothing but 30 by x minus y. And further, if we are talking about the downstream condition for the very first line that is given to us in the question, for the downstream we have taken the time as nothing but t2, and for the downstream we have the distance as nothing but 44 km, and the speed we have taken for the downstream as nothing but x plus y, is nothing but x plus y. So t1 is 30 by x minus y and t2 is 44 by x plus y for the case 1, which is given to us. So it means we have to substitute both of these values in the equation number 1. So from the equation number 1, we can say 30 by x minus 1 plus 44 by x plus y is equal to 10. According to the question, this was our case number 1 and this was our case number 2. So from the case number 1, we have calculated the equation as 30 by x minus y plus 44 by x plus y, which is equal to 10. Now let's just move on further to what the second condition which is given to us. So it says in 13 hours it can go 40 km upstream. So this was our case number 1. So let us suppose I'm writing it over here. This was our case number 1. Let's just talk about the case number 2 we have. So for the upstream, we will take again T1. But now for the upstream, the distance is nothing but given as 40 km. So this is 40 km divided by, as we are going upstream, so the speed would be x minus y. And further we have T2 as nothing but downstream. So for the downstream, we have the distance which is given to us, which is 55 km. So T2 is nothing but 55 divided by x plus of y for the downstream. So T1 is 40 by x minus 1, T2 is 55 by x plus 1. So again, we'll substitute both of these equations, that is from the equation number 2. We will substitute T1 and T2 in the equation number 2. We will get the value as nothing but 40 by x minus y plus 55 by x plus y, which is nothing but is equal to 13. This is nothing but is equal to 13. So this is nothing but the next equation. Let us suppose I'm calling this as nothing but equation number 3rd and I'm calling this as nothing but the equation number 4th. So according to the question, we have given these two equations, that is the equation number 3rd and equation number 4th, and now we have to solve both of these equations for the value of x and y, because we just wanted to find out the speed of the boat in the still water and the speed of the stream. So let's just solve these two equations again. So this was our equation number 3rd and 4th, and now we will solve both of these equations again to find or in order to find the value of x and y. So we already are aware about such kind of equation, that how we can solve them. So first of all, we will reduce them to the linear equation, as first of all we'll take 1 by x minus y. As we can see over here, we have x minus y, x plus y. So we will take let 1 by x minus of y as capital of A, and we will take 1 by x plus y as nothing but capital of B. The same process like we did before in the question. So we will take 1 by x minus y as capital A, 1 by x plus y as capital of B. Let us suppose I'm calling this as equation number 5. So from the equation number 3, we can reduce this equation as nothing but 30 into 1 by x minus y, which is capital of A, plus 44 of capital of B, which is is equal to 10, and from the equation number 4th, we can say this is nothing but 40 of capital of A plus 55 of capital of B, which is equal to 13. As you can see, we have 40 by x minus y. So 1 by x minus y can be written as capital A, 1 by x plus y can be written as capital of B. So hence at the end we are getting the equations as nothing but equation number 5, 6. Let us suppose I'm calling this as 6 and I'm calling this as 7. So this is my 6th equation, this is my 7th equation. Now let's just solve both of these equations by any appropriate algebraic method. So let us suppose I am using the cross multiplication method over here to find the value of capital A and capital B. So let's just solve this equation or this pair of equation as, first of all, we will take the capital A. As you can remember, the cross multiplication method's shortcut was of the form 2, 3, 1, 2. So using that 2, 3, 1, 2 concept, I am finding out the value of capital A and capital B. So let's just start finding out the value. So first of all, we'll write capital A, and below capital A means in the denominator of capital of A, we can write the values as 44 into minus of 13 minus of 55 into minus of 10. 55 into minus of 10. Because we are multiplying the coefficients of B and the constant. So 44 into minus of 13 plus, minus of 55 into minus of 10. So the value is A by 44 minus 13 minus 15 minus of 10, which is equal to capital of B, which is equal to capital of B. So under the capital of B, we'll have the values as nothing but minus of 10 into 40 minus of, further we have minus of 13 into 30, minus of 13 into 30, and further we have 1, the value 1 means we have 1 again. So under the 1 we can write it as 30 into 55 minus of 30 into 55 minus of 40 into 44, 40 into 44. 40 into 44. Now this is the equations or the formation that we are getting using the cross multiplication method into the equation number 6 and the equation number 7. Now let's just find out the value of capital A, capital B and capital A and capital B only. So first of all, we'll solve this equation as nothing but capital of A divided by 44 minus of 13 we have. So this would be nothing but minus of 572. This would be nothing but minus of 572 plus of 550. This is, which is equal to capital of B. So this would be nothing but minus of 400 plus of 390, which is equal to 1 divided by, so this would be 1650. So this would be 1650, as we have 515 and 1650. Again we have a minus of 1760. This is 1760. So let's just find out the values over here. So first of all, we have capital A. We have capital A divided by minus of 22 after solving this, which is equal to capital of B divided by, so this would be nothing but minus of 10, and we have 1 divided by, this is nothing but minus of 1760, 1650. This is minus of 110. Now let's just find out the value of capital A, capital B and capital C by taking capital A and the third, that is 1 by minus of 110 equation. So let us suppose I am equating both of these equal to each other. So the capital A would be is equal to minus of 22 divided by, we'll get minus of 110, negative and negative get cancelled with each other. So this would be 10, this is 2, and this would be 2 into 1 is 2 and 2 into 5 is 10. Means capital A we are getting is nothing but 1 by 5, and similarly the value of capital B, we have to equate both of these equation together. So this would be B, which is equal to minus of 10 by minus of 100, 110. So negative negative get cancelled with each other, 0 and 0 get cancelled with each other. So B we are getting is nothing but 1 by 11. 11. The value of B that we are getting is 1 by 11. Now we have to substitute capital A and capital B again into the equation number 5. So let us suppose I am calling both of these equation as nothing but equation number 8. Now we have to substitute equation number 8 into the equation number 5 in order to get the value of X and Y. So let us suppose I am continuing the process from here. So first of all, we have to calculate the value of X and Y. We have to calculate the value of X and Y. So we are substituting the value of capital A and capital B into the equation, that is equation number 5. So if we'll substitute 8 into 5, so we will get 1 by X minus Y, which is equal to 1 by 5, and again 1 by X plus Y, which is equal to 1 by 11. Take the reciprocal of both of these equations. So let us suppose we are taking the reciprocal. So taking reciprocal, we will get the equation as nothing but X minus Y is equal to 5 and X plus Y is equal to 11. Now let's just solve both of these equations using the elimination method. So as we can see, we have the equation as X minus Y is equal to 5 and X plus Y is equal to 11. So we can subtract all these equations. If we are subtracting them, we can also add them as well. So let us suppose I am subtracting them. So X and X get cancelled with each other. We will get minus of 2y, which is equal to, this would be minus of 6, negative get cancelled. So y is equal to 6 by 2, that is nothing but 3. So the value of y we are getting is nothing but 3. Let's just substitute y is equal to 3 in any of these equations. Let us suppose I am calling this is nothing but equation number 9. Substitute y is equal to 3 in any of the equation. So if we have X minus Y is equal to 5. Let's just substitute the value Y as 3 over here. So X minus 3 is equal to 5 means X is nothing but is equal to 8. So at the end we are getting the value as X is equal to 8 and Y is equal to 3. It means that we are getting the value as the speed of boat in still water. Speed of boat in still water is nothing but 8 km per hour, and further we have the speed of the stream. The speed of the stream that we have taken as nothing but y is nothing but 3 km per hour, and this is nothing but our answer, that is the speed of the boat and the speed of the stream. I hope the solution set of this particular question is all clear to you.